Guys, welcome back. Today's video is on graphing tangent functions. In order to figure out how a tangent function looks, let's fill out a couple points on the table. At 0, right here, the tangent, remember the tangent at 0 is y over x. So at 0, you have 0 over 1, which is 0. At pi over 2, the tangent of y over x is 1 over 0. That is undefined. The tangent at pi is 0 over -1. So that's going to be 0 again. And then if we wanted to do 3 pi over 2, that's also going to be undefined, -1 over 0. So it's kind of like a pattern going around. And let's see what a graph would look like. At 0, we have 0. And then at pi over 2, it doesn't exist. If it doesn't exist, what we're going to put is that it has what's called an asymptote. That's an imaginary line where the graph cannot cross through, and we write it as dotted. And then at pi, it had a 0 again. And at 3 pi over 2, it was another dotted asymptote. So wherever you see a pi over 2, here, you're always going to see an asymptote where the graph cannot cross. Now to see how the rest of the graph looks like, you need to make this sort of curvy cubic shape going up and then back down. This pattern is going to end up going on forever. And what's different about the tangent and between the sine and the cosine, besides the weirder looking shape, is that its period only repeats every pi. So we put period is that full revolution. The domain occurs at all real numbers except when you have every pi over 2. Unlike sine and cosine, where their domain was all real numbers, tangent has asymptotes or breaks in its graph at every pi over 2, where the range, however, is all real numbers. The tangent graph has the same a, b, c, d values that cosine and sine do, where we can transform the period by b, remember. We can change the amplitude by a. We can move c left or right and change d to change the vertical values. So what I want you to do is go to Desmos and fill out the back, change your settings, answer these questions. So pause the video and then I'll bring up Desmos and we can look at it together. Here I'm changing my settings. Let's go from -2 pi to 2 pi. And the step is going to be pi over 2. Just like before, so nothing's changing and you're in radian mode. Here's what the graph's going to look like. If we type in y equals tan x, you do get that weird looking shape. And you see that, if I can zoom in, at every pi over 2, the graph doesn't happen. It's not going to show you the asymptote, but you do see that there's like an imaginary brick wall there. So now if we change A, B, C, and D, let's see what happens to this tan graph. So I'm going to add all the sliders. Changing A. This changes kind of like the slope. So as A gets a little bigger, it kind of straightens out. Negative, it flips the other direction. It's a reflection. And then as more negative we get, it straightens out again. B, kind of crazy. So what B is going to do, it's going to make it more squishy. It's going to change the period. It's going to make it repeat more and more times as B gets bigger. And the same thing going the other way. If B is negative, the bigger it gets, the more it repeats, but it's also being reflected the other direction. C moves the graph left or right, just like sine and cosine. D value is going to move it down or up. And you see how what's moving is that called point of inflection, kind of where the curve goes. Write your answers to what best makes sense to you, how we talked about what A, B, and C and D are. So your answers. At the bottom here. So tell me how all of these are different than the regular tan graph. For example, with a 3 in front, it's going to change the amplitude is now going to be 3. And it's like a more narrow slope. That's what it looks like. If we had tan, let me write it over here, x minus pi, how is that different than the normal tan x graph? So you might not see it here between the blue and the green on the graph, but each one was moved right pi. And because of each graph was moved right pi, it kind of overlaps each other since each of these green graphs occur at every pi value. So even if we did move it right pi, you can't really see it because it's being overlapped. Let's see if I can try. Let's add my slider C. So normally C is 0, but then if I move it to pi, which is 3.14, it's going to overlap and get to almost exactly on the other graph. And that's why you can't really see the difference on Desmos. Again, answer these questions. Tell me how the graph differs, whether it's reflected, moved up, down, left, right, how the period changes. The last thing I do want to end this video talking about is the formula for period. This is the main difference between this sine and cosine. Formula is not 2 pi over b, it's just pi over the b value. Again, the period is only pi for tangent. Let me know what questions you guys have and see everyone next time.